Welcome to the Devtoberfest with the session Best of SAP BW Features in Datasphere. My name is Sandy, and in this session here, I will show you what kind of different BW features we have implemented in Datasphere and how it looks like on Datasphere side. And that will be our agenda for today. So first of all, I will show you how you can define language-dependent text in the context of multilingual support. Then I will show you how you can achieve a currency conversion inside of Datasphere. How do we define time dependency? How to leverage hierarchies in the context of business content? How are navigation and transitive attributes defined in Datasphere? We will shortly address the non-cumulative measures. Then how would we define in general measures in the sense of calculated, restricted key figures? How do we define aggregation in Datasphere? And how do we leverage variables inside of an analytic model? And then we have a short chapter about business content. And now let's dive right into the first feature, and that will be multilingual support. So first of all, we need to differentiate between two different options. The first one concerns language-dependent text, meaning you can define a language dependency for your dimensions and hierarchies. And then on the other side, you can also have a so-called translation dashboard implemented, which enables you to have even the business names, the column names of your dimension and analytic models and other entities translated. And for that, you're going to create the following. So we're having here the data from the respective source system, and then based on the text data, you're going to create a view with semantic usage text. Here there will be an association to the dimension, and again from the dimension creating an association to the fact, because at the end we want to leverage the fact inside of the analytic model in order to show the text with language dependency. First, we need an entity with semantic usage text. So usually you're accessing the cost center text from the source system and then create a view on top. Afterwards, you're going to take care of the following configuration. So here you need to ensure that the respective keys are maintained, especially for the language key. And then in the semantic type area, you're going to select language for the language key and text for the short and medium description. And lastly, in the text and association area, you will select either the medium or the short description, depending on what you want to depict when cost center is selected. In the second step, we are required to create an entity with the semantic usage dimension. Here you're accessing your master data from the source system where you build a view on top. If you have more than one key column defined, then it is also necessary to set the representative key, which is always the most granular level of data. So in our context, we are selecting the cost center. Afterwards, you can then scroll down to the associations area where you're able to add the text association. We're adding the one that we just created, and as you can see, you first need to map the key columns from the dimension to the text, and then afterwards you're able to leverage your dimension with text. So now let's have a quick look into our text data. So here on the left-hand side, you see the controlling area, the cost centers, as well as the respective descriptions in German as well as in English. In order to view the text data, we first need an entity with semantic usage fact. Afterwards, you're going to associate the dimension that we just created with the fact by mapping the key columns with each other. Afterwards, you can directly jump from the fact source into your analytic model here. Now we're in the analytic model where you can see the fact source as well as the dimension that we just associated to the fact. On the right-hand side, you see the indication T, meaning that the cost center has text. In order to preview them, we can click here on Preview and can then select the cost center here. So our expectation would be now that we see the text next to the cost center. So the reason I'm seeing this in English now is because in my settings, I have decided for my data access language to be in English. Now I'm going to switch to German, and it will ask me to reload the page. Once you did that, you will see the same screen again. Now we're jumping back to preview. And now we're selecting the cost center again with the expectation that we're seeing German text now, which is also the case. And there you go. This is how you create text with language dependency. Okay, and that was a quick introduction to the language dependent text. And now let's have a look at the currency conversion. So in this context, you have the option to either import your so-called ticker tables that you need for the currency conversion, or you could also create them manually. Let's have a quick look into our data model. So first of all, we have here our transactional data. We're going to access the data via the fact, and then that will be our underlying basis for the analytic model again. And implicitly, we're also going to consume the currency tables and views from the S4 system. Now we're back in our system. So here we have our fact. And let's go to the below attributes. The first thing in order to leverage key figures in a proper way is to first define the unit of measure as well as the currency with the respective semantic types. So for unit of measure, there is a dedicated semantic type unit of measure, and for currency, we have the semantic type currency code. Once you do that, you go above to the measures. And here you would see that you have the option to define the semantic type again. So we are selecting quantity with unit for quantity and amount with currency for currency. Then it will ask you to also provide a unit column. That is the one that we just selected in the attributes. Once you do that, we have a quick look into our data. We have here the products with the respective unit of measure, quantity, amount, and currency in US dollars as well as in euro. Before we jump into our analytic model, we first need to import the currency conversion data models. So here, either you're going to do that manually or you're selecting the respective source. We're going to access the data from the S4 system, and those will be the respective objects that are being created. And now we're inside the analytic model with our fact source here. We see the dimensions that we already saw in our fact, as well as the measures. Here there is another measure, which is the currency conversion measure. And what you will do is for the source measure to select the amount. This is because we defined the amount as a semantic type here. Then we have here the target currency. In this regard, we're going to select a variable instead, meaning depending on what the user is going to select as the currency, it will be converted respectively. Then for the reference date, we're selecting the current date. And for the exchange rate type, you can change the one depending on what the source system provides you. So here we have the fixed one. Once you do that, you can go to the preview. And then you can enter your target currency. I'm just choosing Australian dollars now. Click on set. Then the analytic model will be adjusted. And you see now that for the amount itself, there is no indication of how high the amount is. Once we select the product, you will be able to see that is due to the reason that here we're having a different currency, which is why it is not aggregated. Same for the quantity, because here we have different unit of measures. And this is how you would define, first of all, the different key figures, as well as a currency conversion variable to convert the amount into the target currency. Okay, that was it now about the currency conversion. Let's talk about time dependency now. So what do you need to consider if you want to achieve time-dependent text in your dimension as an example? So first of all, of course, your respective dimension or text needs to have the valid from and valid to columns. And then for those two columns, you need to define the semantic type, and you need to assign one key either to the valid from and valid to column. And then you're already ready to go to leverage time-dependent data. So that's quite simple and straightforward. And this is our underlying data model. So first of all, I will show you how you would define the time-dependent semantics in our dimension. This one will be then associated to our fact source, which is the source for our analytic model. And in here, I will show you the time-dependent information based on a defined referenced date variable. Now we're already in our product master data table. We have here defined the semantic usage to be dimension. Then in the attributes area, you need to select the key for the respective ID, as well as either for the valid from or the valid to column. Then in the semantic type area, here you need to select the business date from for the valid from and business date to semantic type for the valid to column. And that is the prerequisite in order to leverage time dependency. Let's have a quick look into our master data. So our use case is the following. We have the plastic combining machine being categorized from January 1st to August 31st as subcategory binders, while after September 1st, the plastic combining machine will then be categorized under appliances instead. So now we're in our fact source where we have created the association from the dimension product master data to the fact by mapping the product ID with each other. Having a quick look into our transactional data, we see here the product ID of our plastic combining machine, which has been bought here for 100. And then we see here another entry, which is also bought for 100. And now we're in our analytic model. We have here our fact source, the associated dimension. And then on the right-hand side, I have defined a reference date because based on what kind of date I'm selecting, the subcategory should be different then. So now I'm selecting the default value, which is before the change. Here, for now, it looks normal, but once I select the subcategory, I see that for appliances, we have 391, and for binders, 353 in sales. Then I'm going to refresh again. And now I'm going to select a date after September 1st. So I'm just going to take the 4th. Once I do that, and then go back to the product and then to the subcategory, you will see that binders, as you may recall, is now 200 less, while appliances increases in the amount of 200. And this is due to the fact that we're selecting a time which falls into the time frame where the combining machine is being categorized as appliances and not as binders anymore. And that was a simple example to show you how you can achieve time dependency. Then, moving forward to the hierarchies, Datasphere supports a variety of different hierarchy types that are depicted on this slide here. So we have the parent-child hierarchy, the level-based one. You can also leverage an external hierarchy, which is basically a separate entity, or hierarchy with directory, which is quite familiar in the context of S4. And this is our underlying data model. So what we're going to do first is to import the business content. Afterwards, we will have here the dimension from the business content that is going to be associated to a fact source that we will create in order to simplify the use case. And that fact will then be reused in the analytic model, where we will then see the different hierarchies. In the first step, you will jump to the semantic onboarding app where you will see the business content here. As we want to depict the GL account line items, we're looking for the Finance Foundation business content. Once you click on that, it will show you an overview of the import package as well as the installation guide. Here you could set the preference that the objects should be deployed after the import, and here you would see the overview of the business content and the entities that will be imported into that respective space. After the import of the business content, I have moved the GL account related business content to that space here and filled the tables with the data from the S4HANA source system. And right now I'm in the dimension that we're going to associate to our simplified fact source. So let's have a quick look at the lineage. And as you can see, all the objects here on the left-hand side will be automatically imported by the business content. So the only task that we're going to do is to associate it here now to the fact. And now we're in the fact that we're going to associate to the dimension. So here below in the associations area, you then need to map the chart of accounts and GL account columns with each other. And here you see the fact with the associated dimension, and on the right-hand side we see the GL account with an indication of time dependency, hierarchies, and text. And now let's preview the data to see how the hierarchy looks like. So we have first of all the measures here, then we're going to select the GL account, and now we're going to select the hierarchy. For that, you're going to right-click on the GL account, select hierarchy, then it will show you the different hierarchies. So now I'm just selecting one here. Once you click on OK, it will adjust the preview based on the hierarchy you have chosen. You could drill down then further. And that is how you can use hierarchies based on the business content delivered without the need to manually create the hierarchies yourself. And that was an example concerning hierarchies. Now we're moving forward to another topic, which would be navigation and transitive attributes. So for that, you're going to take the company master data and associate it to the cost center dimension via the company code. Afterwards, we're taking the dimension and create an association in the fact, and that will be the underlying basis for our cost center analytic model where we define the attributes. So here we're accessing our cost center master data where we define the semantic usage to be dimension. And below you have the associations area where you're going to map the company master data with the cost center dimension via the company code. Then we jump into our fact source of cost center where we then create the association to the dimension and mapping the cost center and controlling area columns with each other. Now jumping into the analytic model, we can see that here we have the attributes derived from the fact. Once we click on the cost center dimension that we just associated, we also see the attributes from the cost center dimension. So now let's have a look on the reporting side. So here I'm selecting the cost center analytic model. And if I add dimensions, I will see the ones derived from the fact. If I want to drill down on cost center, I even see the attributes coming from the dimension directly. Now we're back again in our analytic model and let's check the cost center dimension again. So here we will see the associated dimension company code. That is one that we're going to select and will be automatically included in our analytic model. Then I decide for my company code that I want to depict the attributes company name and the country. As for cost center dimension, I do not want to show the attribute the person responsible and the object currency as well as the source system. Once I did that, I'm going to deploy the analytic model and then jump to SAC to see the changes made. And now we're back on the SAC side. Once you have refreshed the page, you should see the following dimensions. So on the one hand side, we have the company code with the column selected company name and country. As for cost center, we deselected some attributes. So now we're only seeing business area and profit center. And there you go. This is how you're going to define navigation and transitive attributes in a similar fashion as you would have done in the BW. All right, and that was it for the navigation and transitive attributes. Now moving forward to the non-cumulative key figures, which enables you to describe the current stock situation in your warehouse as an example, as it appoints the reference point and delta records similar to the BW. The next chapter covers different definitions of key figures. So first of all, you are able to create regular calculated measures inside of your analytic model. Here you can also use several formulas in your expression based on HANA SQL. Or you could also create a restricted measure even with a definition of a constant selection. A count distinct measure as depicted here. The currency conversion measure is something that I've already showed to you in the beginning of the session. And non-cumulative measures are the measures that I've just depicted prior to that slide. Before we jump into the system, let's also cover the next chapter, which would be the aggregations. So inside of your analytic model, you have the following standard types where you could create an aggregation on. And in addition to that, you can also define an exception aggregation inside of your analytic model based on the aggregation that you have defined. Okay, now we're right back in the system and have here our exemplary fact source. You see here, first of all, we have the measure sales amount, and then we have three attributes containing region, the product group, and date. Now let's define multiple measures now. So here we have our regular sales amount measure that I've just shown to you. As you can see here, it's inherited from the fact source. Then first of all, there is a restricted measure here defined. So in our context, we would like to only get the sales from the product group electronics, which is written here in the expression. Okay. Then moving back to the initial screen, we have here now a calculated measure. So when you click on that, you see there's an expression only considering the sales amount if it's larger than 5,000. And then when we jump back, there's another measure defined. So this one here contains an exception aggregation, which you will see once you scroll down. So here we again have the sales amount larger than 5,000. But here below we say, okay, there's an exception aggregation type, which is sum, and that should be applied to the dimension product group. Okay, so we have now all these 4 measures, and now let's see how this will affect the fact source. Okay, so we're going to do a preview now for that. If you look at the preview now as it is without having a dimension selected, you already see some differences. So for the standard aggregation, which considers the sales numbers being larger than 5,000, this is already being fulfilled via the sales amount here. Then you see for the sales group with the exception aggregation, there are apparently 10 product groups which fulfill the condition of having sales larger than 5,000. And then for electronic sales, the number is at least lower, which indicates that the electronics have only been included in this number here. So in order to ensure that, let's quickly select the product group. Once you do that, you see first of all for electronics, that is exactly what is being depicted here. And of course, if we drill down, we see that apparently every product group is fulfilling the condition of having a sales larger than 5,000. And that is why we see for both, for the sales with the standard aggregation and the one with the exception aggregation, we see the same number. And that's basically already it. So this is how easy you could define restricted measures, calculated measures with exception aggregation as well, and also filtering of the respective measure. Jumping back to the slides, the next topic is about variables. So here you need to think of an equivalent implementation similar to global filters in BW. And here you have 4 different variables that you could choose from. So first of all, we have a standard variables that is being used in your fact source, or a restricted one, meaning there is a filter condition, or a restricted measure, which is not applicable to the whole data set. Then we have a filter variable, which is referring to an attribute, meaning of a dimension. And then inside of the analytic model, there's also the option to define a reference state variable in case you have time-dependent data in it. Now we're back in the system. As you may recall, that was our example with the currency conversion. So here below you have the variable section. Here we defined a so-called target currency, meaning in this context, I'm having a value definition of my variable, and that is basically I want to manually input it. You can also have the option to derive the value from another entity. And then here at below, it indicates where you're using this variable. So in this context, I'm using this in order to define a target currency based on what the user wants to depict. So if I go back here and jump to the amount in target currency, I will see that the target currency is not, I will see that the target currency here is basically the variable that I've just shown to you, and you can see that also here below. Okay, so that is now selected. If I go to preview, what happens now is that there will be a pop-up asking me for the target currency. So I'm now just selecting Australian dollars. Once I click on set, we will then have another amount which is depicted in Australian dollars. So if I would now select, let's say, the product as an example, I would then also see for amount the different currencies. And because there are different ones, if I would not have selected the product, I would also not be able to see the total amount of it, unlike with the Australian dollars. And that was basically a simple example on how you can create variables and how to leverage them in your analytic model. Now we're jumping already to our last point here from our list, business content. As I've mentioned in the beginning, similar to BW, we also have business content in Datasphere. And moreover, there's even another option to leverage content, which is community content. Here you can find various of use cases that have been implemented by, let's say, other colleagues as well, and will help you also to successfully onboard to Datasphere, and you might also find some content there that might also be helpful in your context. Okay, now we're almost at the end of the session. Now I would like to cover the outlook, meaning what kind of features we are planning to implement in Datasphere in order to achieve BW feature parity. So as you can see on the left-hand side, that is what I've shown to you now, what we already have. And what is planned for the next year is, for instance, that we want to support the two structure queries as you would have in BW as well. And then furthermore, unit and alpha conversion, as well as the language selection during the import. And another rather not feature related roadmap item would be the support of more data centers. And on the right hand side, you would then see what we are currently not planning to deliver. Yeah. And that's actually already it. So thank you for watching. Hope you enjoyed it and hope you learned a lot on how you can implement the BW scenarios in Datasphere. And see you and talk to you next time again.